Hey guys, it's been a hot minute, hasn't it? Welcome back. We figured it was time that we started making some more content, hey? We have a lot of stuff to talk about, actually. A lot of things have happened since we last spoke. A lot of new developments have come up, and I'll try and keep this a bit short. I don't want it going for too long. I mean, we could probably sit here for hours. So, where are we now with our car? What a lot of people have sort of been asking is that, you made a lot of noise with your engine and your builds and all that sort of stuff. You rebuilt the engine a few times because you came across issues with, the building process of this engine. It is quite a delicate engine to build, and not just us, but the shops and engine builders and stuff that have been involved have learned a lot too, because they've realized that they can't just take what works on an LS or an N55 or a B48, S55, S14, M50, M54. The list goes on. Whatever they have learned on those engines doesn't quite translate quite well to the N20, because it is just it's made out of a softer aluminium. It's got a few design elements in there that just honestly do not make sense from a strength point of view. And that specifically, I'm referring to the cylinders. The rest of the engine block itself is actually really well designed. It's just the cylinders that let down the N20. Predominantly, besides the rods. I'm not going to speak about the rods. We all know that they're a problem. But the cylinder design on the N20 is kind of shit, if I'm being honest. They run two coolant jackets between the cylinders, and like the really small ones, they're about 1.5 millimeters in diameter. Now that reduces the thickness of the cylinder wall between cylinders. So that's a problem. And when you start pushing high horsepower out of the engine, you want thicker cylinder walls to take more abuse to survive. And what we have found is that when you start running sleeves, you run into issues. Now, the factory setup uses what we call I believe it's a plasma wire arc coating, is what's written in the technical documentation. Now, what this is essentially an iron wire melted down to be sprayed on like paint. And the reason why they do that is because it actually bonds better to the aluminium and helps transfer load and heat and all that sort of fun stuff into the aluminium part of the cylinder wall, because you can't really run a piston on aluminium to aluminium and all that sort of stuff. There's reasons why you do this. It's better for friction, it's better for sealing, it's better for power and compression. It's the reason why you'd run some sort of iron or steel liner or material between the piston and the cylinder wall. Anyway, now we have seen a N20 with this plasma coating run 36, 37 PSI boost with no issues. They have closed the block though. That is the one key point to note, because we have seen issues with the cylinders wobbling a bit over 34, 35 PSI. Typically, I'd recommend over 30 PSI that you start looking at closing the deck, because if you don't have the right sleeve design in there, you will crack it, crack the cylinders, or you could have head gasket failure. Now, we have seen reliable examples of, over 30 PSI, like 32, 34 PSI, on an open deck built motor. However, they are running the correct sleeves for the job. And as far as I'm concerned, that's a big contributing factor to why that engine was so successful. It's just the right combination of parts. Now, we have seen flange sleeves crack, and a lot of that was just down to they were the incorrect thickness for the task. I mean, if you're going to go ahead and build an engine, why build an engine with, a 5% or 0% or 10% margin for error? Like, it just doesn't make sense, right? You then basically recreate the stock motor, but just at a higher power output. You don't want that. When you build an engine, you need to have a considerable safety net. I build an engine with 1,000 horsepower. I want to make 800 horsepower out of it. I want to have that safety net, because I don't want to be rebuilding engines. And if something does go wrong, the car runs lean, the fuel pump crashes, whatever, I have that room for a bit of forgiveness. I could blow a piston, or I could torch the cylinder head, or bend a valve, or whatever, and I could replace that. The biggest thing is having to replace the block, the sleeves. It's a pain. And when you run a flange sleeve or a parallel sleeve, parallel liners don't run, okay? They drop. Most of them drop, especially when you start looking at high power, they will drop. And when they drop, they lose compression and they start mixing oil and coolant. It's not fun. But when you run the incorrect sleeve, you reduce the amount of power that you can make. So getting the right sleeve is hard. It is really hard. Here in Australia, our options have been to repurpose diesel engine liners. I think the parallel liner that was originally used was out of some sort of a diesel truck, and then the flange sleeves that we used in the build series that you would have seen on the channel and on Brintech's channel was using, I believe, a Toyota Land Cruiser diesel sleeve. On a stock engine, that sleeve probably would have been fine. And when I say stock, I mean like stock power output engine. It probably would have been fine. As we started increasing the power and we started experiencing limitations of fuel systems and that sort of stuff, we really were pushing the engine pretty hard. And we ended up cracking, I think it was cylinder 1 and 4. I'll have some photos pop up shortly. We actually cracked those sleeves right around on the inside of the cylinder. And on one of them, I think we cracked the top of it as well. Now, the head gasket obviously failed. The pistons are totally fine. The pistons do not care. The rings actually look okay as well. So it's amazing that they held up to it, but the sleeves failed. If anything, the sleeves shouldn't have been the first thing to fail. So I think that just goes to show they just were not correct for the application. Now, what we have looked into is, well, what's the solution? Now, the client that made that 530 horsepower, he's running an open deck flanged sleeve engine, but he's using Darton flanged liners that were purposely made for that engine. So I don't know the specs of those sleeves, so I don't know exactly what they used. They may have, from technical sort of talk point of view, you could, if you really wanted to, make the flange sleeves remove the coolant jacket between cylinders to gain wall clearance. You would run the risk that the engine runs a bit hotter, but after seeing the data on this engine, this car runs totally fine. So if they did do that, then there's clearly no detrimental effect to removing those between cylinder coolant jackets. Or they could have just run a sleeve that was actually correct whilst maintaining that between cylinder coolant jackets. The sleeves that we ran in the build series on this engine, the flange ones, they honestly could have been about a 0.2 to 0.3 millimeters thicker. And that probably would have helped us quite a lot, to be honest, in terms of strength. I think they were 1.21 millimeters thick. Don't quote me on that. I think that's what they were. Point is, they cracked, they failed. Moving on, what do we do? Okay, so we had two options. Could have gone to like either LA sleeves or Darton and gotten flange sleeves made up. Because of the pandemic, the lead time was apparently going to be 4 weeks. Then we would have had to close the deck anyway, just as a safety precaution. Now, we initially opted, when we rebuilt Ken's motor, to remove the closed decking was because it's a street car. We didn't really find that to be overly beneficial to do. We didn't think we were going to have issues with the deck moving. As it turns out, it's not the case. So we thought, well, all right, how can we flange this? Now, here in Australia, if we got flange sleeves and then closed the deck, we would have been running almost the same price as the Darton wet liner, which incorporates both those. So we thought, all right, how about we get wet sleeves made up? Now, Darton could have made us wet sleeves in 4 weeks because that was the delay with COVID and stuff, but they could have done it. The problem we had is that the dimensions we actually needed 1 millimeter diameter larger sleeve than what they had in what they call the blank. So basically, a blank is just a preset casting before they machine it to size, which was a pain because it meant we needed to make custom castings of our sleeves. That in itself, because of the lovely pandemic, instead of being, I think the original timeline was like 6 weeks, was like supposedly 14 to 18 weeks. Anyway, 6 months later, we finally got them. That's not Darton's fault, like we can all be annoyed about it, but I mean, a lot of the automotive industry is taking a long time to get things done now because the pandemic has not just affected the automotive industry, it's also affected the IT industry. Has anyone tried buying a graphics card lately? But, it is extremely hard to get a hold of parts. So yeah, Darton took 6 months. CP Carrillo now are taking anywhere from 6 to 7 months to get rods and pistons made. It took us 3 months to get studs out of ARP. They're just delays. I mean, one of my mates took, I think it was 7 months to get bearings from King. It was just wild on these delays. Not all of them are manufacturing delays. Most of them are logistic delays, really. And that's outside of their control. So if you're going to build an engine at the moment, I'd say, yeah, be really aware this could take you over a year to just get the parts at this point. I mean, look at us, we're 4 years in, and I know that we've done 3 rebuilds so far, but I'm at a point where I'm lucky enough to have taken it. It took me 2 years to acquire most of the parts. It wasn't just because of pandemic stuff. There was other reasons behind it too. But we're at a point now where, I mean, especially in Sydney, Australia, our lockdowns have sort of eased off, and we can start moving around now. We've got a bit more free time to get out and about and speak with shops and whatnot, and get things made. Brintech has been absolutely awesome with the collaboration we've done with them in getting parts made, and the baffled oil pans have been a great product. Really helped, and they're doing all our engine builds. So if you've seen Mighty Car Mod's Black Chops episode with the E30, and you've seen Tony build that LS engine, Tony is the guy that's doing our engine builds from now on. We were using other shops in the past. We didn't get overly great experiences out of them. Brintech, to be honest with you, is the place to be. It's the place I'd recommend. And Tony has been a great asset to them from what we've seen so far. And we're really excited to see what the future is going to bring for us with engine rebuilds, maybe even offer crate engines. Who knows? But we are basically pushing Darton Wet Sleeves essentially on the N20, just because it makes the most sense to just do it all in one go. It's a great safety net, and we designed these sleeves to be replaceable. Most sleeves are an interference fit. Now, that doesn't mean you can't replace them. It just means that you need to get a slightly oversized sleeve. Getting an oversized sleeve can be really hard depending on who made the sleeve and what's available. So what we did was we made a replaceable sleeve, so it uses O-rings to seal the sleeve into the block rather than being an interference fit. Now, interference fit means that the sleeve is technically larger by like a few thousandths of an inch than the block, and you either heat the block up and cool the sleeve, or you do vice versa, or you do both, or whatever, and then you drop them in, put them on a press, hold them in place till they all cool down and stabilize, and then they're held in place with friction. Not ideal, really, to be honest, with the amount of rebuilds that I've done and the rebuilds that we do for clients and all that sort of stuff and whatnot. It's not worth it. So we've gone with a easily to replace sleeve material, or design rather. And we've come a long way. I think we've got the N20 now at a point from a built point of view where it's going to be reliable. It's going to make a lot of power. The B48s have been pretty fortunate because of how low kilometer they are. A lot of people don't even do a hone on the engine. Now, pet peeve, rebuilding an engine, you really should hone the block. The B48 block has actually a thinner wall material than the N20 does. So if you're going to hone it, you can't actually hone the B48 for that matter. You can't even hone the N20's block with the plasma coating. If you hone it, you need to reapply it. Simple. And that technology is becoming a bit more freely available to some people. Even in Australia, I think we now have someone that can actually do it. So it is becoming more of an available process to do, which is great. It's going to really benefit the community in doing so. Installing sleeves on B48, look, no one's done it yet, because like I said, there isn't actually a lot of built B48s going around anyway, mainly because the stock motor is pretty damn reliable at high power. But look, going forward, we will look into doing some more B48 engine builds and that sort of thing. The biggest issue we have is just turbos and fuel system stuff. Really, it's all the supporting stuff. I mean, CP dropped N20 built parts, almost as immediately as they did with the N55 and S55. But the problem is that it's all well and good to make these parts, but then you need to have supporting parts. I mean, for quite a long period of time, there was this sentiment in the N20 community that stock N20 fuel system can run E85, and then those that do end up having an engine that blows up after a few months because the fuel, the air to fuel ratio mixtures are just too damn lean, or they have injector issues, or like the list goes on, because you're asking a fuel system that technically can't actually deliver it. I mean, we did the numbers on it. It can't deliver it, and okay, the B48 is a little bit better in terms of fuel delivery, but we'd still recommend a fuel pump upgrade on the stock engines just for that literal safety net. The fact that you should run the AFRs a bit richer than what, factory and even some tunes do. You wonder why the B48 cracks pistons. I'd say a fair chunk, not all tunes, all right? And I'm not having a go at everyone's tuning in those companies, but I'm just saying that we have seen some tunes on the B48 particularly that run quite lean. Now, this is okay on good fuel. On good fuel, and that's provided that it's not extremely lean, because there is a threshold. Sometimes lean is okay, depending on how lean it is. Other times lean can be really bad, and depending on the fuel. If you're running really low quality fuel, do not run lean. And on a 4-cylinder, you shouldn't be running lean, to be honest, in general, because 4-cylinders are under more stress, they're under more heat, right? When you run leaner, you run the risk of detonation, and B48s have been known to crack pistons because of that. So point in case, fuel system needs to be upgraded. N20, B48, same. But that's the problem, is that we need these upgrades. People have been building motors, and I guess the reason why no one really realized that these upgrades were needed is because most people that have built an N20 or a B48 haven't been slapping big turbos on them. They've been slapping a stage 2 on them, because companies go out there and go, oh, we rate this to 400 horsepower or 400 wheel horsepower or whatever. And it's like, yep, good job. You've read the compressor map. But that's not what the turbo will make. The ratio of the turbo essentially on the turbine housing is just too small. I mean, the TDO 4-base turbos for the B48 and the N20, it's a 6 cm squared housing. It's a 0.41 AR housing. It's really small. To push anything over 300 horsepower to that housing is asking for issues, to be honest. Like, yeah, you can do it, but like, it's the reason why we don't actually really recommend a stage 2 or stage 1 turbo. We only recommend those turbos if they are cost effective. In other words, good value for money. And there's only like 4 turbos on that list that qualify for good value for money. Otherwise, we would prefer that you just don't even bother with it. You'd be better off just running E85, to be honest, on a stock turbo. I mean, heck, that makes almost a stage 1, stage 2 turbos 93 numbers anyway. So, you know, I'd recommend against those turbos. The same on the B48. The B48 TUs typically do have actually better turbos. They are a slightly better design. But yeah, there's lots of things that go into this sort of stuff, you know, and you really need to sit down and don't rush this sort of stuff. You want to make sure that you get the right combination of parts, you know, and we do now have stage 1 injectors for the N55. For the N20. We do have them for the N55 and S55, obviously, but the N20 now has stage 1 injectors. The N20 now has access to stage 2 injectors. Thank you, Nostrum, for your S55 work. Thankfully, we can just clone that over. Problem is that we don't have a fuel pump that's rated to high enough fuel flow to support a stage 2 injector on an N20. So that won't be a thing that we can really do. We do have stage 1, stage 2 fuel pumps now. Thank you, Spool, for your FX150 offerings and 180 offerings. Now, as you're aware, the FX150 on stock injectors is not a viable solution, just because we need to run higher fuel rail pressures on stock injectors on the E85 to get the fuel flow out of the injectors. So that leaves you with a B48 TU high pressure fuel pump, which has pretty much been the go-to for a lot of stock turbo guys, is just to run a B58 TU pump. It is becoming cheaper now too. Like, you can get them for like $400 for a Bosch branded one, give or take, depending on where you get it from and supply and whatnot. But you can run that pump, you can run it at 3,600 PSI rail pressure, and you won't have injector limitations. Whereas if you run like an FX150, it can only support 2,900 PSI, which you should only be running on the S63 TU EU5 injectors, the stage 1 injectors for the N20, because those injectors flow more fuel at that lower rail pressure. So that's a better combination of parts if you were to buy a spool pump for whatever reason. The FX180 from Spool will run 3,600 PSI, no problems, and it is good for stock N20 injectors. But the problem is that it's really expensive. So if you're going to buy one, I'd hope that you're running a lot more than 320 horsepower out of that engine. And to use a stage 2 injector, you need a stage 3 high pressure fuel pump, which I don't think anyone has designed. So that leaves you with those that are wanting to make more than 700 horsepower. You're going to need to look at PI. Simple, you will need PI. And probably even a dual LPL, like low pressure fuel pump upgrade, so like a stage 3 low pressure fuel pump kit, combined with probably the upgraded EKP from EOS, because otherwise you have to run a hop switch to run the secondary pump. You can't run 2 pumps off of the one EKP with the fuel pump control module. And those that run a low pressure fuel pump, a Walbro 525, you will need to upgrade the EKP module. It will torch your stock module. The stock module can support a 87 PSI variant of the Walbro 460 pumps, because they don't draw really any more than 20 amps, which is the maximum that thing, the EKP, can pump out, which is the part number ends in 267 for that Walbro 460 450 pump. The Walbro 460 450 pump that ends in 274 is the higher pressure version, and that draws up to 22, 23 amps. It will cause issues. I have learnt this the hard way. It melted my harness on my low pressure fuel pump bucket. Don't buy it. It's not worth it. All that aside, that's where we're up to with the N20 and some of the B48s. Now, in terms of turbo stuff, I will touch lightly on this stuff for the B48s before I get in and actually show you guys the sleeves and the turbo I've got here. Basically, what we have done is we actually managed to get a hold of a. For most of you guys in the US, you will have access to this car, but it's an M235iX, so the Grand Coupe. Or coupe, as you may call it, the 2 Series. It's basically an M Light B48. It comes out with like 306 horsepower stock. The car runs 26 PSI boost stock. It's absolutely awesome. The turbo makes 26 PSI boost at 3K RPM. It's insane. And we've seen it do 29 PSI on one of our tunes, which has caused it to flow about 43 pounds per minute of air. And anyone that knows turbos knows that that's pretty damn good numbers. So that typically would make about 430 horsepower on a dyno jet on 93, give or take, or 430 horsepower at the crank for all the other people that use load bearing dynos, aka the low reading dynos. But the point is that turbo actually exceeds some of the stage 2 turbos that the B48 currently have. Even the B48 TU turbo, which is technically also a Garrett turbo, it's actually smaller than the one that's found on the M Light B48s. So it's a great option to upgrade. It's extremely efficient. I mean, it makes 26 PSI boost at 65% wastegate duty cycle. Damn, really good. I mean, you imagine making 20 PSI on a Gen 1 B48 turbo, you're running like 80 to 90% duty cycle. So yeah, it's pretty good. It runs a 0.61 AR housing, which is the largest housing for a 4-cylinder turbo BMW engine that I've seen. Like I said before, the B48 Gen 1s and the N20s run a 0.41 AR housing. The B48 TU runs a 0.57 AR housing. So it is inherently better. It is a bigger turbo than the B48 TU, by the way. The difference is, for those that don't know, the B48 TU runs an MGT 2056, so a GT 2056 turbo on a 0.5756 AR housing. That turbo pretty much maxes at 310 wheel horsepower on 93 or 98 run. Whereas the B48 A20 TO1, aka the B48E, or even referred to as the B48 T1, which is basically the M Light B48 I mentioned, that comes in the M235iX Grand Coupe. It also comes in the M135iX and the 35iX X3 and the F60 JCW Mini. There are a few models only from 2018 to 2019 pretty much, and some, I think, really early 2020s. BMW only made this a short run setup for whatever strange reason. But it's a great turbo. It's almost a G25 550, and it's almost a GTX 2867R Gen 2. It's very similar between the two. There are some clear design cues from both turbos. Awesome. Honestly, awesome turbo. So we recommend that now as an upgrade to Gen 1 B48 owners. It's not quite plug and play compared to a B48 TU. There is some slight modifications that need to be made to the bolt hole on cylinder 4 on the turbo mounting flange. There is some slight things that need to be adjusted on the coolant oil lines, and some intake and charge pipe changes because the outlets are all different and whatnot. You'll see when I show you the turbo. It also uses a DV, so you can either leave the DV there, because it should actually stay closed when it's unpowered, or you can create a plug to plug the DV on the Gen 1 B48 since you don't use one, or you could wire the DV up to a Hobbs switch and have it trigger at your maximum boost pressure for safety reasons. It does use the same electronic wastegate controller as the N20, N55, S55, B48, B58, B38, so they're all the same. It looks a bit different, but it electrically speaking, it's the same. It's honestly a really impressive turbo. It does actually reuse the B48 downpipes. So you don't have to swap those out for those that want to know. We ran this on a Mini Cooper with a 10.2 Gen 1 B48 engine at 26 PSI, which is pretty much stock boost for this turbo. It ran 360 horsepower and 565 newton meters of torque on our load-bearing, low-reading dyno, which for you dynojet guys, it's like 414 wheel horsepower. And I think it was like 640 or 650 newton meters of torque on a dynojet converted. That was on E50 though, just as a bear in mind, that was E50. But point in case, it made 400, crank horsepower or whatever, or wheel horsepower. It made good power, and it made more power than what a stage 2 turbo would make. And spool up is insane on this. Compared to the G25 660s that we run on the built B48s, this thing pumps. I mean, what a lot of people don't realize is that once you start ramping up over 400 horsepower, you start really dropping down that 2,000 to 4,000 RPM torque. And as we've seen on the G25 660s with a 0.72 housing on those built B48s, we are making less torque than stock, between 2,000 and 4,000 RPM. The built N20 that we've done, it has dropped torque in that RPM range, but it actually hasn't dropped it that much. So the boost is down, but it's not too bad. That's actually probably a turbo configuration I'd recommend even on a stock engine, just with a bit less boost, because you'd still make good power without actually running high torque. And that in itself is great for the N20, because we know the N20 hates torque. But yeah, anyway, so this turbo is awesome. What we're doing now is we're actually going to slap 2 of these. Yes, I know, sounds crazy. We're going to slap 2 of them to our build N20. So it's been a while. Our N20 obviously hasn't been, really going anywhere. We've been on lockdown and, all that fun stuff with pandemic, whatnot. But we're now at a point where we can actually get our motor back together and start enjoying it. And after seeing all the built N20s and B48s and realizing that big single turbos can be, I knew that they were laggy, but I didn't realize that we were going to make less than stock torque between 2 and 4K RPM. And I daily my car, and I live in Sydney. I don't want to be running an NA car in that power band. It's horrible. It's terrible. It's not worth it. So basically, what we're going to do is we have 2 options, right? Now, a lot of guys that work in the import scene with 4-cylinder engines, Honda and the like, probably are very aware and accustomed to compound turbo setups. We could have run one. The problem you have on an electronic wastegated B48 and N20 is, how do you control a second wastegate if you want to maintain the electronic wastegate control, which, to be honest, shits on pneumatically operated wastegates? The answer is you can't really, because the DME only has 1 plug. The DME documentation states that it can supply 9 to 16 volts and 6.6 amps to the wastegate. It doesn't state its PWM, or pulse width modulated frequency, so we'd need to work that out when the car's running. It doesn't state whether or not that's the max amperage that it can support. It just says this is what the system draws. Now, obviously at lower voltage and at higher loads and that sort of thing, you will draw more current. That's how electronics work. But from bench testing so far, we believe that we could probably do 2 of these wastegates off of the 1 connection, and it shouldn't draw much more than 7 amps under load. That's the theory. We're going to have to test this on the car running to see what sort of pressure is loaded up on the wastegates. Hopefully not too much. But we're actually going to look at doing a twin turbo setup rather than a compound, just because compounds are a little bit more complex. Plus, I really don't want to be loading this engine up with 50 pound of boost. It's more work. It's more things I have to add to the engine, and frankly, I don't want to do that. I don't want to add more stuff to the engine just to handle 50 pound of boost even if we're only going to make 700, 800 horsepower. I'd rather just run that at lower boost, but avoid the conundrum of turbo lag. So I was looking at upgrading the B48E, or that upgraded B48 turbo I mentioned, to a stage 2 turbo, but the parts don't exist, and I really do not have the time to get them developed. So I thought, all right, well, I'll just run one of them and call it a day. The problem with that is I've spent a lot of time and effort and resources and whatnot on this engine, and the engine is going to be built for 1,000-ish wheel horsepower, or 1,000 horsepower-ish support. So why not make the car make that much power? Well, like I said, I didn't want to sacrifice the low-end drivability, so I figured, why don't I do something that not many people do, is twin turbo a 4-cylinder. The reasons why you don't do this is because there are things like exhaust gas pulses distribution, loading the engine up, and all that sort of technical sort of side of things that can be negatively impacted with a twin turbo setup compared to a single turbo. However, I got a good feeling that the turbos that we've got are going to be correctly matched to feed this engine in a twin scroll or a twin turbo environment. Both these turbos are twin scroll as well, so that shouldn't hurt our spoolability. Basically, what we plan to do is run cylinders 1 and 4 on one turbo and 2 and 3 on the other turbo. The reason why we elected to go twins versus compound is, 1, we don't add more work to the engine and we don't load the engine up as much. 2, we can get spool-like capabilities of a 400 to 500 wheel horsepower turbo, but make 700, 800 horsepower out of the turbo, because you don't quite double it, but you almost double the flow rate of a turbo when you run a twin turbo configuration. So if the turbos flow 42, 43 pounds per minute each, I would expect to double it, almost double it, and say we'd probably flow around about 75-ish or even 70 pounds per minute of air. So 700-ish horsepower support or wheel horsepower support, depending on what dyno that you use. So I think that's going to be something I'm going to do. I'm going to go give it a try. Now, if the DME does not like running 2 wastegate controllers off of one harness, I have a solution with using an Arduino controller to sort of take the DME signal and then just basically relay it into 2 separate signals that'll be fed with their own power supply, so we can run the extra current that we need. So I'm planning to get the car over hopefully end of this month into the shop to get work started on it and get it out of the garage and hopefully get driving it soon. That'll be fun. So what I'll do now is I'll flick over and I'll show you the turbo and I'll show you the sleeves. So what I've got here is the B48E or B48T1 or B48A20 T01, however you want to call it. I have the turbo here. This is one of the 2 that we're going to slap on my car. This is also the upgraded turbo that I recommend for pretty much most B48 Gen 1 and B48 TU guys. Obviously, the car that this comes off of needs its own upgraded turbos, but that's still something that needs to be worked out. But basically, as you can see, this is what I was talking about with the turbo inlet. It's its own design, so you'll need to make your own intake. It uses a diverter valve. The DV that BMW use on this is insanely more durable than the one on the N20. It's really, really good. I don't know if the fitment is the same as the N20 or the N55. I have to check. But really good. I've removed the electronic wastegate for the time being because I'm doing some testing. As you can see, this is what I was talking about with the flange. This is actually pushed in a bit than these flange connections. So you need to either weld another flange just about here on this, or the bracket that holds this, you need to sort of customize it so that it'll properly seal that cylinder so you don't have exhaust leaks. We've got some people in the Discord community already that have slapped this on their car, and they've got some photos of how they've done it on a Gen 1 F-Series car. Really impressive turbo. I love it. Here we have the Darton Mid Wet Sleeves for the BMW N20 that I have designed. Really impressed with these. Darton have done a great job of these for us. Now, they are individual sleeves. I know that there was an Instagram post to put up where they're all together. That's because it's what they look like in the engine themselves, but this is all individual. These cutouts here are for the cylinder head bolt holes. As you can see, there's a little one here and there's one here. What's ironic is that the 4 corner bolt holes aren't in the same location on the head, on the block, which is kind of annoying, which is why the holes are they look different. And the 2 that are bigger is because there is the alignment dowel pins in the block on those 2 corner ones, which is why they're a bit different. So that's those, but basically you'll notice that the wall thickness is a bit thicker on the end cylinders just because there's a bit more room for us to play with. But in between the cylinders, we only have a maximum of 7 millimeters of wall thickness. Now, that's total. That's including the coolant jacket. What we ended up doing with the N20 is, with these sleeves, is we removed that coolant jacket between cylinders. It's gone. Does not exist anymore. We did that because we wanted to get as much thickness as possible. We designed these sleeves to be able to support an 85mm piston, but we do not recommend running that piston size. No more than 84.5mm. Otherwise, you start compromising wall thickness. So unless you are really stuck and you needed to run an 85mm, then run one. They are custom. They have to be custom made from CP. But yeah, don't run an 85mm piston, basically. This is what they look like. So I'll put it down here so you can see it. These grooves here, these are for the sealing O-rings, so we can replace the sleeves if they are damaged. This is how we got away with not having to require a interference fit on the sleeve. Now, you'll notice the sleeve is not notched for the upgraded con rods, and the reason why we did this is whilst most options on the market are a H-beam style rod, if a user does run an I-beam rod and they do not need to notch the block, then what's the point of notching the sleeve? So we've left this so that the engine installer, engine builder can notch the sleeve manually, which is why we've left this. These grooves here are what Darton call their register fins. These help cool the block down. You may be able to see it. There is a slight groove here. This is to allow coolant to pass through the cylinder. We did delete it, but like I said, the reason why I have said we've pretty much deleted it is because this gap between two cylinders is 0.5mm, which is like a third of the size of the OEM one. So to be honest with you, I don't actually think it's going to do anything. So, but we've virtually replaced cooling in between the cylinders. We've had this coated in Darton special coating, which is why it's black looking in color. Look, it's a pretty heavy, it's a pretty solid. These are here for the coolant to pass through, and these have been lined up for the head gasket to work. You know, these are a really beefy sleeve, and that will close the deck and seal you in place. Honestly, awesome that we finally have them. I'm so happy that we got them, and they're going to change the game for the N20 market. Basically, how this sleeve works is that it sits in the block and is held in by compression, essentially. So it sits down. There's going to be a register, what we call a register, or basically a platform in the block that will stop the sleeve from going any further here. There'll be a register here. Get the focus. There'll be a register here, and then there'll be a register up here on the block deck. Okay, and that's how the sleeve will essentially sit in place. So it can't go up or down. It won't go up because the cylinder head will stop it from going up, and it won't go down because it's going to be held in three different places on the engine block. So, but that's our sleeves, guys. It's pretty exciting times ahead, and we're going to try and get some videos and some build content out of my engine rebuild with this crazy turbo setup, and you know, we're going to have a video more on these sleeves as we get some install videos going in the coming weeks as well. So yeah, hopefully everything comes together. Hopefully we can get some stuff, you know, out the door in the next few months with this engine. And I know we've done a lot of rebuilds on my engine anyway, and even on Ken's engine. And we've made a lot of developments and stuff, but you know, when you look at the first few videos we made on this channel and the first forum post that I made, you know, back in, it was like late 2018, a lot's changed, because what we realize is that, you know, and this is no disrespect to any of the tuners out there, but I built the engine, or we had shops build the engine, or whatever. Like, there was that collaboration between myself and some of the shops and whatnot. But so it only made sense that because I knew this engine better than any other tuner out there, that I started to go out, and I knew I would have to be the one to tune my engine when I started building this, after I had very mixed results with, you know, other tunes out there and whatnot, and what power we had gotten. And you know, I know that those tuners are quite capable on other engine platforms, and that's fine, but when it comes to, you know, the N20, and as we've now found out with the B48, they're just not that great. And a lot of the reason is just because no one really cares about the four-cylinder market that much, other than the people that own them. So the development just isn't there, which is the reason why I have a lot of time and resources into developing this platform, learning this platform, you know, tuning and all that stuff. I mean, I spent well over 300 hours tuning on my car, and you know, and working out how these DMEs work, because they're not like a traditional Haltech or Link, you know, ECU. They're quite an advanced and sophisticated setup. So learning how to tune these, I mean, you can take basic concepts of how, you know, engines, petrol engines, combustion engines, etc., can be tuned and how they operate, and that can be applied to these cars. But
to understand how to calculate what power you want to request out of these cars. Totally different ball game. Very, very complicated to learn. Once you understand how it works, you pick it up, right? But it's not easy, especially when no one shares this information. So a lot of people have to learn by themselves, and they have to learn the hard way. So I'm thankful that I've had the opportunity to do a lot of that learning, a lot of that training, and a lot of the opportunity to do a lot of testing and understand how these engines work, and really drive good tuning and good modification support, and just good technical analysis and documentation for this sort of N20 and B48 platform. It's been really good, and I really do believe that, the 4-cylinder game is only getting started. Yes, we will have to move over to electric vehicles at some point in the next 8 or so years, but I think we're going to have a huge peak in 4 cylinders before then, and 6 cylinders are going to start dying off. I wouldn't be surprised if the next iteration, I thought this current generation of G Series M cars were going to be 4-cylinder, but obviously not yet. I would assume, considering BMW's already put a P48 in their M4 DTM car, it will not be long before we get an M 4-cylinder engine like we did on the E30. So I think driving development now is going to be hugely beneficial for us, especially into the future. So I am committed to developing, more tuning opportunities and parts and services and guides, and I really want to help push this community forwards. I really want people to have fun on these cars. I know that, there are inherent risks with tuning, and everyone who is in this should be aware of that. And it is unfortunately a pay-to-play industry. It just, that's how it is. Like I said, you're increasing power above stock, and there's a reason why manufacturers don't warrant tunes, because it's not what the engine was designed for. They do have a margin of error, but then again, like I said, most tunes occupy that margin for error that they create. So, as we go forwards, I am committed to trying to push this development and get things done. We've got a cool few things in the pipeline: upgraded intake manifolds, turbo manifolds. I've got an upgraded oil cooling and oil filter thing that I've been pretty quiet about that I've got coming soon. And we now have, even for the N20, we've got aluminium valve covers that have popped up on AliExpress and whatnot. I haven't tried them yet. Hopefully they're as good as they sound. We've got a lot of fun things coming. We've had, like I said before, we've got the fuel system upgrades now. Next step is proper turbo setups. As much as I love the CP, or not even CP, but just the upgraded rods and pistons, I do want to try and see if we can get some I-beam forged rods, because that would help a lot of people just use them as drop-in replacements on a stock engine. You don't have to notch the cylinders, you don't have to take the engine out. But it's not quite the upgrade we want. If we could get S55 rods, perfect. The problem is you can't buy them individually, and they're almost as expensive in a set of, once you break down the set of 6, they're almost as expensive as a max speeding rod or an SP Components con rod for an N20. So I don't think it's really that beneficial at that point. I'd rather them be a little bit cheaper, especially since you don't need to notch the cylinders for them. So we're trying to drive development anyway on that front. And we're really thankful to you guys in the community for your continued support. Really excited to see what the future brings for the B48 and the N20. Hopefully this year is a year where we actually get quarter mile times for all those high horsepower cars, because we sort of don't have them. I've been told by the guys running the B48s making 500 plus wheel horsepower that because of the turbo lag, they're getting 12.1 seconds on a quarter mile. And apparently the users that are running a stage 2 B48 TU turbo are getting, with 390-ish wheel horsepower and 98 RON and meth injection, heavy meth injection, mind you, are getting around 11.8 to 11.9 seconds. Now, this is just what I've been told. I haven't seen slips. I can't confirm this, but those numbers, if they are true, are pretty disappointing. But like I said, I've seen the dyno chart for those big turbos, and if the torque is lower than stock, not surprised, which is why you really should be looking at like nitrous injection or a compound turbo setup when you want to get over that 500 wheel horsepower mark to make decent times, to be honest with you. And also make sure you get the right turbo pairing as well, because I do believe that the turbo matching for those 500 plus B48s is not quite right. Probably could have dropped the turbine housing just a little bit, or maybe gone for a G25 550 instead at the same housing ratio, like it just depends. There's lots of factors when it comes to these sorts of builds, so take your time. If you're going to do one, take your time, get as much information as you can, and make the correct decision for yourself. But anyway, on that note, I hope you guys have enjoyed this conversation. I plan to do a bit more, content throughout the year, and hopefully some more actual hands-on video content. I'm even open to some Friday night live stream videos with questions and stuff. If you've want to ask me questions on live stream or whatever, I'm open to that idea. I'm really active on the Discord community, more so, or obviously on Navardi Tunes messaging and stuff. But if you want to contact me a bit more freely, Discord is probably the place to be, just because it's easier for me to access that. Otherwise, hit me up on my emails or Facebook Messenger or Instagram. Anyway, guys, thanks for watching, and I'll catch you later.